Hello. Hello, everyone. Can you hear me? Say something in the chat. Perfect. Good. All right. So familiar faces. Good to see you. So today we're going to talk about equations, and you've probably seen the new paper. And I'm going to share my screen, and here we are. So basically, I want to show you some tricks when dealing with equations. So we're going to have some easy equations, some harder equations, so some various equations. And I want to start with equations with modulus. Okay, so let's have a look. Right. The most efficient way of solving equations is probably with modulus. Is probably graphing them. But they can also be solved algebraically. Okay, so let's have a look. You have an equation, modulus of x minus 1 is equal to x minus 1. You should be able to see my screen. If you don't see my screen, let me know. I've made this mistake before. Okay, to the latest. Right. So let's go to the definition of modulus. And so what is the definition? Modulus x is equal to, now this symbol is not used a lot in A-level maths, but this means or. So in maths, this symbol means and this symbol means or. Okay. So modulus of x is x if x is positive, and it's equal to minus x if x is negative. Now, we don't have to put greater or equal. We could just as well put a third line saying it's equal to 0 if x is 0, which is kind of obvious. The modulus 0 is 0. So what we do is we combine the first line and the third line, and we say, well, if it's greater or equal to 0, it's x. Okay. So this is the definition of a modulus. The modulus of x is x if x is positive or 0, and it's equal to minus x if x is negative. So we can apply this rule here. And before we do anything, we can ask ourselves a question: well, what can x be? Are there any limitations on x? Are there any limitations on x? Limitations on x. Basically, it's called the domain of the domain of the equation, sometimes referred to as the domain of the equation. What is the positive possible values of x? And let's have a look. The left-hand side is a modulus. There are no restrictions on x here. Okay, no restrictions, because x can be anything. You can take the modulus of any number without any restrictions. However, the number on the right is equal to a modulus. So the number on the right has to be positive. So x minus 1 has to be greater or equal to 0. So x has to be greater or equal to 1. Okay, that's a limitation on x. And we just keep this in mind. Keep in mind. All right. Is it clear for everyone why x has to be greater or equal to 1? Okay, anyone not clear? I'm happy to explain. Okay. All right. So we go for we go along. So what is modulus x? Well, using the definition, modulus x is equal to x minus 1 if x minus 1 is greater or equal to 0. And it's equal to minus x plus 1 if x minus 1 is less than 0. So it's equal to x minus 1 if x is greater than 1. And it's equal to minus x plus 1 if x is less than 1. But we already know that x has to be greater than 1. So we can discard the second option. We can discard that. Okay, so discard. So we're left with the equation x minus 1. So x minus 1 is equal to x minus 1 because x is greater or equal to 1. Okay, so we have the equation becomes x minus 1 equals x minus 1. This is called a tautology in maths, tautology. It's a statement that is always true. For example, x equals x is a tautology. In other words, we can subtract x, add 1 to each side, and we get 0 equals 0, which is always true. Always true. So x can be any number within the limitations of your problem. Therefore, x greater than 1 is the answer. X is any no, there's no real difference. Identity and tautology are the same thing. Any number. Tautology. Spelled tautology. Now I need to double check that it is actually spelled like this. Yeah, tautology. Okay. The moral of the story, the solution to an equation could be a range. Could be a range of numbers. So basically, the solution to this equation is not a single number, but it's any number which is greater than 1. And you can check any number that is greater than 1 is a solution. And any number less than 1 is not a solution. You could also use a slightly different approach here, which I will demonstrate in the second scenario. So, are there any limitations here? Well, not obviously, and we won't go out of our way to search for any restrictions. Because this could be any number, because there are no restrictions on x cubed plus 8. And this can be any number, positive or negative. So there are there's really no restrictions here. These are, yeah. Or at least if there are restrictions, it's not obvious. So we don't go there. It's just, it helps us, but if not. Okay, so we deal with the modulus. With the modulus, we say, okay, x plus 2, modulus of x plus 2 is either x plus 2 if x is greater or equal minus 2, or it is minus x minus 2 if x is less than minus 2. So they will call this case number 1 and case number 2. So we deal with them separately. 1, case x is greater or equal minus 2. We solve the equation x cubed plus 8 equals 3x, x plus 2, and this becomes a cubic equation, x cubed plus 8 minus 3x squared minus 6x equals 0, x cubed minus 3x squared minus 6x plus 8 equals 0. So if the equation has integer roots, they are factors of the term with no x, right? So I hope you know that. If you have integer roots, they are factors of 8. So what are the factors of 8? Well, plus minus 1, plus minus 2, plus minus 4, plus minus 8. Hopefully we won't need to get to 8. So we start testing. We're testing 1. Well, 1 certainly is it there? Oh, actually it might work. Let's see if 1 is a solution. 1 minus 3, that's minus 2, minus 6, 8, plus 8. Oh, perfect. X equals 1 is a solution. X equals 1 is a solution. So I'm going to factor out x minus 1. So that using the factor theorem, we say that x minus 1 is a factor. Is there anyone here who has no idea what I'm talking about? Have you done the factor theorem, basically? Do you all understand what I'm doing? I'm saying that x equals 1 is a solution, so x minus 1 is a factor. Okay. So you've done so I'm assuming you've done the factor theorem at in your A-level course, in your year 12 course, without specifying whether you do A-level or something else. Okay, so x minus 1 is a factor, and therefore we can factor out x minus 1. So you can use long division. I prefer using so there is if it's, that's a good question. Well, how do we know? If it has an integer solution, it must be a factor of the term without x. Well, I could show this. I'm not sure I can prove it to you right now in under 3 minutes, but let's say you have x minus a multiplied by x. Well, if you're able to factor out x minus a. So if a is a solution, and here you have x to the power n, an, x to the power n plus. So basically you have a polynomial here plus, and let's say the final number is b. So this is a polynomial and the final number is b. And it has its solutions. So a is an integer. So a is an integer. Then if you expand this expression, the final term, it would be something plus something plus something plus, minus ab. So assuming b is an integer and a is an integer, that means this integer is divisible by a. I don't think I can prove it right now, but I think I've showed it that this number has to be divisible. If a is a solution, this number has to be divisible by a. Right, so I will factor out x minus 1. So I'm going to do it the following way. So x cubed. Now, what do I need to factor out x minus 1? So it's going to be minus x squared. Because x cubed minus x squared is if you've x minus 1. X minus 1 is a factor of this. But I had minus 3x squared, so I do minus 2x squared. So you can see what I've done, if I've taken minus 3x squared and I've split it into minus x squared minus 2x squared. Minus, okay? But here you can see that I can factor out x minus 1. Minus 2x squared, to factor out x minus 1, I need plus 2x. So now I can factor out x minus 1. But I don't have 2x, I have minus 6x. So I say minus 8x. So I split minus 6x into 2x minus 8x. And finally, I have 8. So you can see I have 3 groups, which I can, from each group, I can factor out x minus 1. So I have x squared, x minus 1, minus 2x, x minus 1, and I have minus 8, x minus 1. And thus, I have x minus 1, x squared minus 2x minus 8. Do you understand this method on a scale of 1 to 10? And also indicate if you've done this before. Has anyone done this method before? Okay, you understand but haven't done it before. Okay. Okay, so that's good. So you have x minus 1, and you can factorize the rest. Super easy. X minus 1, minus 2 plus 8. So that's oh, that's embarrassing. So adding to minus 2. So minus 4, x minus 4, x plus 2. Yes. So the solutions are x equals 1, x equals 4, and x equals minus 2. but we had a limitation. We said that x is greater or equal -2. And that means they are all suitable. So this is suitable, this is suitable, this is suitable. Okay, now we look at the second case. 2, case x is less than -2. The equation becomes x cubed plus 8 equals 3x minus x minus 2. So the difference is that this became negative. So I can solve this. This is x cubed plus 3x squared plus 6x plus 8 equals 0. So same options, plus -1, plus -2, plus -4, plus -8. Let's have a look. 1 testing. Well, obviously it's going to be negative because it can't be not negative. So let's try -1. -1 plus 3, that's -2, that's 2. 2 minus 6 is, no, that doesn't work. So -1 is not suitable. Let's try -2. -2, that's -8 plus 12 minus 12 plus 8. Ah, perfect. So -2 is a solution. X equals -2 is the solution. So you can factor out x plus 2. So x cubed plus 2x squared plus x squared plus 2x plus 4x plus 8 equals 0. So we can factor out x plus 2 in each case. So x squared, x plus 2, plus x plus 2, plus 4, x plus 2 equals 0. And then I do x plus 2, x squared plus x plus 4. Ooh, I don't like that at all. Okay, so this doesn't factorize as far as I understand. Yeah, there are no numbers that you can add to 1 multiplied to 4. That doesn't work. Yeah, so I have to use, so x equals -2. That's the first solution. And the second one, well, I'm going to use completing the square. I'm too lazy to do the formula. So plus x plus a quarter minus a quarter plus 4 equals 0. So x plus a half is equal to plus or minus 1. Oh yeah, it's going to be negative. Okay, that's going to be squared. And this is going to be equal to minus 16 minus 15 over 4. Yeah, so negative, no solutions. If we say x, there are no solutions here. Now the only solution is x equals -2, but we have x is less than -2, so not suitable. So not a solution. Not suitable. Therefore, x belongs to empty set here. So there are only 3 solutions which are here. And the easiest way, well, using technology, and you probably have fancy calculators on you nowadays during the exam. So x cubed plus 8, y equals x cubed plus 8. That's the first one, and 3x y equals 3x modulus x plus 2, is it? I believe so. X plus 2, yes. So you can see where they intersect. So they intersect at -2, 1, and again they intersect at 4. So 4, 1, and -2. Actually, no. Graphical methods are super powerful, especially when you have these Casio CG50 calculators. So some of you use them for exams. So we draw the 2 lines. We have 4, 1, and -2. And this is the solution. 4, 1, -2. Perfect. Okay. So the next one is done in a very similar way. Let me see if there's anything exciting about this particular question. Maybe we skip it. Yeah, but I mean, it's worth trying. It's worth. Okay. Would you like me to go through problem 3, or are you happy to move on? Tell me, please. Yeah, but vote. Go through or move on? Happy to move on. Okay. Right. The next one. Okay. So this is, well, this is the multiplication to 0 rule. Basically, you have 2 things which multiply to 0, so one of them must be 0. The question is, what are the limitations? Well, look, limitations. So domain, let's call it the domain of the equation. And we have a square root, and the square root, the thing under the square root has to be positive. So x is greater or equal -2. Well, x plus 2 is x plus 2, x plus 2 has to be positive or 0, has to be non-negative. In other words, x is greater or equal to -2. That's one thing that we need to keep in mind. The other one is this square root, but this is x cubed plus x minus 1 has to be greater than 0. Now, this is not an easy one to solve. I would say don't bother too much here because it's a difficult one to solve. So what do we want to do? We'll just keep that in mind. Keep in mind. So if you get a solution, we'll just have to test it. Does it work here? Okay, so and here, so it's because it's a multiplication of two numbers and it's equal to 0, one of them is 0. So either x squared minus 9 is 0. So x squared is equal to 9. X is equal to plus minus 3. And now we remember this. X is greater than minus 2, so x is 3 is a solution. We tested, is it greater than 0? 3 squared 27 plus 3, 29, greater. Yes, so it's suitable for this one. So yes, it is a solution. And the second one, so first and second, or square root of x cubed plus x minus 1 minus square root of x plus 2 is 0. Okay, so one of these, so this is 0, so we put that to the right hand side. Square root x cubed plus x. This is equal to 0, like this. Okay. X cubed, we square both sides, x cubed plus x minus 1 equals x plus 2. X cancels, so we got 3, x cubed equals 3. X is equal to cube root of 3. Is it suitable? Well, it's definitely greater than minus 2. Is it suitable here? X cubed is 3. 3 plus cube root of 3 minus 1. So that's more than 0. So that is a solution as well. So these are two solutions. So the answer is x equals 3. X equals cube root of 3. And it would be good to say x1 and x2. Okay. So the domain of the equation, in this case, domain of equation. So square root of x plus 2, well, square root, you can only take the square root of a positive number, of a non-negative number. Therefore, x plus 2 has to be greater or equal to 0. In other words, x has to be greater or equal to minus 2. That's your domain. Now, and then you remember, so the modulus x minus 1 is equal to x minus 1 if x is greater than 1, and minus x plus 1 if x is less than 1. So we have two options. First, case 1. X is greater or equal to 1. That's the first option. And then the equation becomes square root x plus 2 equals x minus 1. So we remove, by doing this, we remove the modulus. So we square both sides, x plus 2 equals x squared plus minus 2x plus 1. So x squared minus 3x minus 1 equals 0. And this is don't like it. I made a mistake. No, I haven't, but add to 3, multiply to 1, there's no. Well, yeah, there's nothing really you can do about it. Just use the formula. So x1 x is equal to 3 plus or minus square root of 13 over 2. Okay, so you have x greater than 1. So 3 minus square root of 13 is going to be negative. So the negative one is not suitable for us. So it has to be, the first solution is 3 plus square root of 13 over 2. Because the negative one, the one with the minus is not suitable. Because it's not consistent with the with this. 2, case 2. Now x is less than 1, but we remember also the domain of the equation. So it has to be greater or equal minus 2. So greater or equal minus 2. So in this case, it's minus, so x plus 2 equals minus x plus 1. Okay, that's funny. You'll see in a bit why, because when we square it, it becomes the same thing. X plus 2 is equal to x squared minus 2x plus 1. Okay, it's the same equation. It's x squared minus 3x minus 1 equals 0. So x is equal to 3 plus or minus square root 13 over 2. So the positive one doesn't suit us because it's more than 1. So 3 minus square root of 13, 3 minus square root of 13 and 2. So we need to compare it to minus 2. So how do you know whether one of them is bigger or not? Well, is it less or minus 2? So compare. So step 1, assume 3 minus square root 13 over 2 is greater than minus 2. Then 3 minus square root 13 is greater than minus 4. Then you take 4 to this. So 3 plus 4 is greater than square root of 13. Then 7 is greater than square root of 13. Square it, 49 is greater than 13. True. Right. Therefore, the initial assumption was true. That means the initial 2, 3 initial assumption was true. I actually wanted to do it the other way around. So if you assume that this is less than minus 2, you will have a contradiction at the end. And once you have a contradiction, you say, oh, well, that means the initial assumption wasn't true. So this is how you compare two numbers without a calculator. You assume one thing, and then you calculate the consequence of that assumption. And if the consequence makes sense, that means it is true. If the consequence doesn't make sense, it is untrue. Okay. The short answer was true. So therefore, because this number is greater than -2, we can, so x, the second solution is 3 minus square root 13 over 2. But now, having second thoughts about this question, you are allowed to square it. You are allowed to square both sides, and you would have the same result. So maybe I just overcomplicated it for myself. But the point is the approach. The approach is the point. You can't always rely on being able to square both sides. Hope that makes sense. So what you could have done from the very start, you could have said, okay, let's square this and this, and modulus of x minus 1 squared. So whatever x minus 1 is, its square is going to be positive. So yeah, you would arrive to the same result. Any questions? Any questions here? Anything you'd like to? So what I'm trying to say is like solving equations is, you look what you have. So you kind of always have to ask yourself, what's in front of me? What are the limitations? Because equations are not are sometimes just not solvable by normal methods. Okay. So, for example, well, I'll get to the example. Yeah, I'll get to the example. We'll see how it goes. But yeah, let's look at a separate example. So well, let's have a look. So for example, sine x equals x. There's no algebraic way of solving it. If you know one, I'd be happy to hear. I would be happy to hear it. But can somebody give me the answer? Can somebody solve this equation? Yeah, 0. It's obviously 0. That's the problem is proving that's the only solution. And this is where it gets complicated. Like x equals 0 is a solution. X equals 0 is a solution. But is it the only one? Is it the only one? And it is, but it's not easy to prove. So one way of proving it is drawing. And you say, okay, so this is the sine graph. And this is the y equals x graph. And they have one point, y equals x. And this is y equals sine x. So you can see that they only have one point, which is 0. And no other points. This is one way. How to prove that? How do you know that they are always like this? Well, you kind of need to prove that x. You need to prove that x minus sine x is always greater than 0. Can you prove that? Well, we can try differentiating it. We can find, so f is equal to that df dx. That's going to be 1 minus cos x. And this is greater or equal to 0. Okay, so the derivative is non-negative. That means that f is a non-decreasing function. It's a increasing function. Increasing function. So basically, f is always increasing. So the distance between the line and the graph is always increasing. And we know that the distance between the points at 0 is 0, and since it's always increasing, so we can show that. But you see, like, proving that there's no other solutions requires either graphing, or it requires finding the derivatives. There's no algebraic way of just solving it. Why am I deleting it? So that's what I'm saying. Equations are not always what you are used to. You know, when you have an equation and you just bam, 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 solve it. Yes, you take x to one side, x to the other. Sometimes it's just not suitable. There are numerical methods that you study as well, which are brilliant. Your calculator uses numerical methods to calculate roots of equations. Do we know this is true, or we're just here to discover a method? Well, you need to look. Mathematics is all about proof. Somehow, proof has been pretty much removed from the school syllabus, unfortunately. But to solve an equation means to find all the roots, or to prove that there are no roots. So every statement you make in mathematics has to be backed up by logic. It has to be a logical sequence. Usually there are more than one ways of proving something. But here you can use calculus to say that the difference of the two functions is an increasing function, and therefore, if they meet once, they will never meet again. This is one way of doing it. So this is a method. I mean, it's not a typical method for solving equations. It's just the first thing that came to my mind, how to prove it. So I know I can prove it using calculus. A graph, but I mean, graph is not a real proof. Like, how do you know that there are no points? You need to be able to prove it. You can use the graph and the derivative in conjunction to prove it. Yeah, so sorry, I'm getting and blabbering. That's the word. Now, how about this? Sine x equals 1/2 x. Well, what can you say? What can you say about this equation? Can you solve it? Sine x equals 1/2 x. Can you solve it? Yeah, but x equals y is a tangent. Are you talking about this one? Is a tangent. So what are you trying to say? You're saying that 1/2 x is not a tangent, therefore there must be at least two values. Yeah, yeah, that is true. How many solutions do you think it has? 4. Oh, not 4. Well, one of the solutions is 0. X is 0 is definitely a solution, because if you put 0, sine 0 is equal to 0. So the difference between the two is very small. It's a very small difference. The graph is more slanted. So how many solutions? Three. Yes, we have 3 solutions. So x1 is 0, x2 is question mark, x3 is question mark. And as I said, there are no algebraic methods of doing it. I don't know if we can solve it. I think we can solve it by using derivatives. So at this point, the distance between them is 0. I'm not sure, but let's try. So let's say f of x is sine x minus 1/2 x. So the derivative of f is now that won't work because the derivative cos x minus 1/2. No, that won't help. So this must be equal to 0. Like, honestly, I can't think of a method of finding the exact value. You can find the approximate value, but not the exact value. So there are definitely no algebraic methods of doing it. You can use numerical methods to solve this equation. You can solve it on a calculator by all means. But calculator uses numerical methods once again. Numerical methods is when you basically it's a guessing. It's a fancy way of doing trial and error. Okay, numerical methods. It's just numerical methods allow you to do trial and error faster than you would normally do trial and error. That's the whole difference of trial and error and numerical methods. But trial and error is a numerical method as well. So it's just one of the numerical methods. If you haven't met numerical methods, you'll enjoy doing them. Yeah, that won't help you if you're doing, okay, sine x equals 1/2 x. So x is the inverse sine of 1/2 x. That won't help you either. So you see, you know that there are three solutions. It's easy. You can easily prove that there are three solutions. Finding the solutions is it's a much tougher task. Here you can find one solution. It's good. Here there are three solutions. There's no easy way of finding them. Okay. Numerical methods. I'd go with I would go with a numerical method here. I would yeah, just start searching. So how I would approach it. How would I approach it? I would x is equal to 2 sine x, and start with x is equal to x1 is 0.5. Let's say x is equal to 2 sine ounce. I don't know if this will work. Probably not. So 0.5 equals 2 sine ounce. Oh yeah, I got a solution. 1.89. 1.895. So this value is, so x2 is approximately 1.895. I used a numerical method. So what I did, have you done numerical methods? No. Yes, no, okay, no. Do you want to see how I did it? Yes, good. So what you do is you say, I want to find the solution. Okay. I want to find the solution to this. I write down, I find x. Then I say, I know that x is somewhere around 0.5. That's my initial guess. So x1, I'll call it x0, is 0.5. That's my initial guess. I'll guess. And then so to find x1, I do 2 sine x0. And this would be approximately, so it's going to be 2. So on a calculator, because I have my Casio calculator, what I do is I say 0.5 equals 0.5 equals, and then I do 2 multiplied by sine ounce. Make sure you're in radians, and then you just keep pressing equals. Keep pressing equals until you get closer and closer to the actual value. So 0.5 equals, so I just put 0.5 equals, then I say 2 sine answer like this, and I press equal, and it's going to be 0.9588. Then x2, to find x2, I just press equals again. It gives me 1.637. Then I get x3, which is 1.9956, 1.9956, and I keep pressing until the number on the display, on the calculator display, stops changing. So I keep pressing until the number on the calculator display stops changing. Sometimes you need to press it more than once. 5, 4, 5, 5, 5, 4, 5, 4, 5, 4, 5, 4. But this is my approximate value. So x, once you press it infinitely many times, is approximately 1.8955. And this is the approximate value. And you can do this many times over, and you get the solution with infinite approximation. So this is a numerical method to find. They don't always work, numerical methods, so you will study them in year 13. Okay. So hopefully that makes sense. You can find the other one starting with negative 0.5, and you can find the approximation. But you'll, because of symmetry, it's plus or minus. So what am I trying to say? I'm trying to say that solving equations, you have to employ all your mathematical knowledge sometimes just to solve equations. So you analyze it, you look at what you have on the left, you see what on the right, are there any restrictions, what are the variables, etc. Okay, the next problem is, I love these. This is called an equation with a parameter. Equation with parameter. With a parameter. And so A is the parameter. Find all values of A for which the equation has exactly one root. Okay, so what can we do about it? With the parameter. Well, we can certainly start saying, well, so imagine A is 0, and we look at the equation. What happens if A is 0? And then we do A is 1, A is 2. But obviously that won't work, because you need all the possibilities. You need all the numbers. So let's try to wiggle around. So ax plus square root 5 minus 4x minus x squared equals 3a plus 3. I would obviously leave square root separately. So I'll put this here, minus ax. And okay. Do I want to square it? Honestly, I don't. You could square it, but then on the right you'll have just something horrible. What I'm going to do, I'm going to use a graphical method. The beautiful thing here is that the left-hand side does not contain a, which is good. So this shape is fixed. So I'm going to draw it. So use a graphical method. Graphical method. Y1 is equal to square root of 5 minus 4x minus x squared. And the second half is y2 is equal to minus ax plus 3a plus 3. That looks... So this is a curve, but this is obviously a straight line. And just with different a's, it will look differently. So let's have a look. A affects both two things. A affects the gradient, but it also affects the y-intercept. So this is the gradient, and this is the y-intercept. So A changes both. Let's see if we can play around with it. So y2 is equal to minus a multiplied by x minus 3 plus 3. So it is a straight line, but look at this. This thing is always 0 if x is 3. So when x is 3, if x is 3, y is also 3. So 3, 3. So it's a straight line going through the point 3, 3. So 3, 3 belongs to the line y2. y2 equal, well, y2. Okay? Do you notice that? Oh, Amanda, why did I pick 0.5 initially? Just from the graph. I look at the graph and I look at the graph and I say, well, it's more than 0. Perhaps it's more than 1. It's just a guess. You could start with any number and you will end up with the same result. If you start with 2, for example. Well, I don't know if you start with 2. 2 sine answer. Yeah, you will. You will end up with the same number if you start with the number 2, for example. So you know that there must be a root, and you find yeah, just it was a guess. So this is a straight line going through the point 3, 3. 3, 3. So a minus a is the gradient. Minus a is the gradient. And that's already something. It's a straight line going through 3, 3, and a determines the gradient. Let's look at the left hand, the first equation. It looks horrible. Let's try squaring it. So y squared is equal to 5 minus 4x minus x squared. X squared plus 4x plus y squared minus 5 equals 0. Okay. Ooh, let's complete the square. X squared plus 4x. So completing the square, that's x squared plus 4x plus 4 plus y squared minus 9 equals 0. Yeah, is everyone happy with that? I'm happy to explain what I did here. What I've done is I've completed the square. And you can see that this is x plus 2 squared plus y squared equals 9. Ooh. That is a graph. But the only limitation here that we have to take into account is that y is greater or equal to 0. Because y is equal to the square root, so y has to be positive. Therefore, this is y greater or equal to 0. Okay. So we went for a graphical method. We draw it. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So we have a straight line going through this point, 3, 3. And this is a circle of radius 3 going through the point minus 2, 0. Minus 2, 1, 2, minus 2, 0. And it has a radius 3. So 3, 1, 2, 3, 1, 2, 3. And y has to be positive. So y cannot dip into the negative side. So it's going to go like this. So this is it. X, and this is y. And it says for which values of a, the equation has exactly one root. And because the gradient can be anything, this is one case, and this is another case. In the first case, the gradient is 0, so a is 0. Yeah, it's a straight line, it's a tangent. And in the second case, you can see that a gradient is 3 over 2. And that means a is minus 3 over 2, because minus a is the gradient. So it's minus 3 over 2. So the answer is a equals 0, a equals minus 3 over 2. Okay, how well do you understand this problem on a scale of, oh, how did I do it? Well, I found the gradient of this line. So this is 1, 0. This is 3, 3. I just calculated the gradient as rise over around 3 over 2, 3 on 2. And because I know that minus a is the gradient, because here, because this is the gradient of the line. So if you look at this line, minus a is the gradient, and 3a plus 3 is the y-intercept. Which point? The point 3, 3. Because I looked at this expression, so I modified this and I said, okay, look at this. If x is 3, then this is 0. If x is 3, this is 0, so y is also 3. Oh, 1, 0. Oh, because, I see. I see what you mean. Okay. So, look, I have to pause here. Yes. So bottom line is, the left-hand side of the equation is a semicircle. So I figured out that this is a semicircle. And this is a straight line. Line going through 3, 3 with gradient minus a. So I've drawn the semicircle, it's fixed, but the line is not fixed. The line can go any way. You go like this, or 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 like this. So the line can have any gradient, and I've made a mistake, but I will remedy myself. So the first possibility that a is 0, this is that, because this is one solution. Because the question is, for which values of a, it has one solution? Well, it has one solution if it's a tangent. So in this case, a is 0. What are the other options? Well, it has to be bigger than this and less than this. So this is a equals 0. This is a equals minus 3 over 2. And here, a is, so that's 3 over 3 plus 5, 8, 3 over 8. 3 over 8 minus 3 over 8. So the answer is a is equal to 0, or a is between minus 3 over 8 and minus 3 over 2. Now, minus 3 over 2 inclusive and minus 3 over 8 non-inclusive, because at minus 3 over 8, it has 2 points of intersection. So let's be a bit more dramatic. Let's have a look here. Right. So Desmos is a super powerful tool for this. So y is equal to square root 5 minus 4x minus x squared. 5 minus 4x minus x squared. And ta-da, it is a semicircle as predicted. Y equals ax minus ax plus 3x plus 3. And it says add slider. As you can see, add slider, bam. That's all right. Where did it go wrong? Minus ax plus 3a plus 3. Oh, plus 3a, of course. All right. And we have the ability to change a. And look what happens when we change a. As we change a, this slope changes. But one point remains the same. So you can see that indeed it goes to that point. I'll be even more dramatic. X minus 2 plus 2 equals 0.1. Yeah, it's a rhombus. It looks like the equation is almost the same as a circle, but with the modulus instead of square, and that gives you a rhombus, well, a square. And so, just so you know, I like this equation. So let's have a look. So you can see that the line always goes through 0.33. Yeah. So as you can see, so when a is minus 1.5, it gives you one solution, one solution, one solution, one solution, one, up to 3/8. Well, it doesn't do 3/8 here. What's 3/8? 0.375. Yeah, 0.375. Up to 3/8, it has one solution. Then it starts having two solutions. It starts having two solutions, until it's 0, when it has exactly one solution. So the question is, when does it have one solution? Here, up to this point, and up to this point, and at this point. Okay. Does this question make sense now? you were very shy in saying, does this question make sense? 100%. What about the rest? 1, 2, 3, 4, 5. Good. Good. So do we have time for more problems? Well, I'll skip 7, 8, and 9, and 10 and 10. I want to go through problem 10. Maybe somebody can help me? Somebody help me? X is 1 is the solution. Very good. So sometimes you can just guess it. X equals 1 is the solution. Oh, the question is to prove that there are no other solutions. Well, what do we know about 2/5? So it's a number less than 1 to the power of x. So it's a function that looks like this. It's an exponent, which it's a negative exponent, and this is a negative exponent. So adding 2 negative exponents, well, not negative exponents, this is a decreasing exponent. 2 decaying exponents will produce a decaying exponent. So this function is a monotonic decreasing function. Monotonic decreasing function. We can prove this by differentiating, for example. Not the easiest thing to do, but why not? Of x is equal to (2/5) x ln 2/5 plus 3/5 x ln 3/5. And we know that ln 2/5 is negative. This is negative, so that's negative. So the derivative is negative for any value of x. F(x) is less than 0 for any value of x, for any real number of x. Therefore, f of x is decreasing, is a decreasing function. Okay. Right. So if f of x is a decreasing function and y equals 1 is a constant, so y equals 1 is a constant function, y equals 1, and this function is a decreasing function, what can we say? Depends on the context then. I'd say 1-to-1 function instead of monotonic. 1-to-1. It's the same meaning. Although not all monotonic functions are one-to-one. But yeah. It's a monotonic function, therefore, if it has a solution, it is the only one solution. If one function is a constant and the other one is constantly decreasing, they can only meet once. Only meet once. That's a sad story. Meet. And that means x equals 1 is the only solution. Okay, I'll have to stop here, and we'll go through some more problems. I hope this was useful, and hope you enjoy the problem set. It's quite a large one, but I imagine it's not the most difficult one. Would you agree with me? I don't know if you would agree with me. You've seen the problem set. Is it the most difficult one or not? Out of the maths ones. I think taking that to just take a while. Okay. I think the sequences in series was the harder one. Reasonable. Okay. All right. See you next week then. Enjoy the longer days and better weather, and yeah, closer to summer. See you. I'm glad. Okay.